Hello, we are from Group 8 and we will be presenting on our topic, which is waste management in Malaysia. So the title of our project is Waste Segregation, Recycling and Composting with Intelligent Waste Management System. So basically, waste management is becoming a big issue, especially in cities, because waste keeps increasing, but most of it is still not properly separated. When everything is mixed, recyclable and organic waste cannot be reused effectively and most of it ends up in landfills. To solve this, our system introduced smart waste segregation using sensors or intelligence classification to separate waste automatically. This helps improve recycling accuracy and reduce human error. Then, recyclable materials like plastic, paper and metal can be processed again, while food waste can go into composting. This is important because organic waste actually produce harmful gas in landfills, but compost can be reused as fertilizer. We also include smart monitoring and incentive to encourage people to dispose waste properly. Overall, the goal is to reduce landfill waste and improve sustainability using smarter technology.
Well, our objective is to develop an intelligent waste segregation system using AI cameras and sensors to automatically classify waste into recyclables and organic categories. And second, we will convert the organic waste into useful fertilizers using a process called composting process. And the third one will be to promote responsible consumptions to maintain a circular economies in our society. Well, our smart will be specific key functions is automatically waste segregations using composting of organic materials, measurables on AIs is classifications accuracies, real-time data updates, and also the certifications level by the users. And the third one is achievable by utilize ready available technologies such as microprocessor sensors and also AI. And relevance is related to current environmental challenges, particularly waste management and also sustainability regarding to SDG. And finally, its time bound is around 25 months for the system.
Assalamualaikum and greeting everyone. My name is Syafiq Berjaya, no metric 801050. Next look at our we are executing the project and shown is our work breakdown structure. WPS is organized into 5 key operation phase. The first and second is project planning and idea development, where we establish our baseline schedule, budget and map out technical feasibility and risk assessment. The third is hardware design. This address core physical and electrical layout including smart bin circuitry, sensor integration, power management and simulation. The fourth is software design. Here we focus on creating the IoT communication network and training our YOLO machine learning model for waste classification. The third is post-design task, ending with our final technical reporting and customer training programs. This systematic workflow guarantees 5 distinct categories of project deliverables. The first is governance and engineer blueprints. We provide the official project characters alongside comprehensive system technical specification for the hardware, YOLO architecture, and specialized composing design. The second is physical and IoT infrastructure. This delivers a fully assembled intelligent bin featuring calibrate ultrasonic, weight, and temperature sensor. The third is validate software platform, featuring our fully testing YOLO classification model with accuracy evaluation report and live data monitoring dashboard. Finally, hand over a maintenance support. We will wrap up with a fully performance verification testing and step-by-step preventing and corrective maintenance protocol.
So this slide shows the project network plan. It summarizes all the project activities, their predecessors, and the project timeline from start until completion. The project begins with the planning stage, such as defining objectives, identifying requirements, scheduling, and budgeting. Then we process to literature review, feasibility analysis, system design, laboratory development, compost monitoring, data analytics integration, system testing, and finally, documentation and customer training. This network plan helps us organize the workflow systematically and understand the relationship between each. So this slide is the first part of the CPM diagram. CPM stands for critical path method, which is used to identify the sequence of critical activities that determine the total project duration. This section covers the early stage of project, starting from planning, literature review, feasibility analysis, system design, development, and composting activities. So this slide is a continuation of CPM diagram. This part focuses on data analytics, integration, system testing, optimization, final reporting, documentation, presentation, and customer training. From CPM analysis, the overall project duration is estimated to be 25 months. Activities on the critical path cannot be delayed because they directly affect the project completion. Thank you.
Our 25-month plan is structured into 10 main phases. We begin with project planning and literature review in month 1 until 4, covering intelligent waste systems, IoT technologies, and YOLO object detection. Months 4 until 8 focus on feasibility analysis and system design, including spy simulation of the smart bin circuit. The core technical work runs from months 8 to 16. We develop the IoT communication system, train a YOLO waste classification model, and integrate cameras and sensors. With lab verification, simultaneously, our composting laboratory stream runs months 8 until 12, handling organic waste collection and quality analysis. Months 13 to 20 cover data analytics integration, building the database, analyzing segregation, accuracy, and creating dashboards. This leads into overall system testing in months 18 until 22, functional integration, and performance evaluation. The project concludes with the final laboratory report and customer training in months 22 until 25. Through all 25 months, weekly supervisor meetings ensure continuous progress monitoring. This structured timeline reflects our commitment to delivering a complete, tested, and documented smart waste management solution.
To ensure the reliability of our bid, we conduct an FMEA risk assessment. This process identifies potential failure mode, essentially what could go wrong, and assign an RPN score based on severity, occurrence, and detectability. The high score indicates a more critical need for a solution. For example, one failure mode under waste detection could be incorrect classification. Picture a scenario where poor lighting lead to AI to confuse plastic bottle with tin can. This could result in recycling contamination, so we plan to enhance our lighting control and improve our dataset. Our most significant risk, user interaction, which has an RPN of 336. When users dispose of improper waste, it slows down the system. To address this, we implement smart feedback mechanism and clear labeling. In the end, the FMEA not only help us build a smart bin, but also create a robust system designed to manage real-world challenge effectively.
To determine the limitation and execution of our project, we first conducted a SWOT analysis. Through this assessment, we identified strengths such as AI-based waste segregation and sustainable fertilizer production. At the same time, weaknesses including high implementation costs and system complexity were highlighted. We also recognized opportunities for wider deployment and collaboration with Aslam, where threats such as cybersecurity risks and rapid technological changes were taken into consideration. Based on these factors, we concluded that the main limitation of our system are the high implementation costs, the need for regular maintenance and calibration, limited accuracy when handling mixed waste, and dependent on user participation. As for the exclusion, our project does not cover hazardous waste handling, waste transportation service, or large-scale facility construction, and limited cybersecurity scope as the system is focused on smart waste segregation and processing at the source.
This slide breaks down our technical requirements and financials, proving every ringgit has a specific purpose. We allocated 20,431 ringgit for our core hardware and sensors in Task D. Our main investment is 138,400 ringgit for the AI vision system in Task E. Adding 5,000 ringgit for site training, our total technical budget comes to 163,831 ringgit, fully funding all project milestones. In conclusion, our intelligent segregation system goes beyond just basic automation. Ultimately, this project actively promotes responsible consumption and significantly enhances environmental sustainability. By bridging AI technology with daily waste habits, we are supporting the development of smarter, more efficient urban waste management systems for the future. Thank you.